Intercepting a missile is essentially like trying to hit a bullet with another bullet while both are traveling at several times the speed of sound. Modern missile defense systems rely on a complex network of satellites, radar stations, computers, and interceptor missiles that work together within seconds. When a ballistic missile is launched, early warning satellites in orbit detect the massive heat signature produced by its rocket engines. These satellites use infrared sensors that can identify launches almost immediately after liftoff. The first stage of a ballistic missile's journey is called the boost phase. During this stage, the missile's engines are firing and pushing the rocket out of the atmosphere. This is the slowest portion of the missile's flight, and theoretically the best opportunity to intercept it. However, it is also the hardest stage to target because interception systems would need to be positioned very close to the launch site, which is rarely possible in real-world conflicts. Once the rocket engines shut down, the missile enters the midcourse phase, which is the longest part of the flight. For long-range ballistic missiles, this stage can last 20 to 30 minutes as the missile travels through space along a predictable ballistic path. During this period, ground-based and sea-based radar systems take over tracking. Advanced radars calculate what is known as a trajectory ellipse, a prediction of the missile's flight path and its likely impact point. This calculation is crucial. If the tracking systems determine that the missile will land in an empty desert or the ocean, interceptors are usually not launched. Interceptor missiles are expensive and limited in number, so defense systems prioritize threats heading towards cities, military bases, or critical infrastructure. If the system determines that the incoming missile poses a real threat, interception procedures begin. The type of interceptor used depends on the altitude and speed of the incoming projectile. Modern missile defense systems rely on what is known as a layered defense architecture, where multiple interception systems operate at different altitudes. The outermost layer operates outside the atmosphere and attempts to destroy long-range ballistic missiles while they are still in space. Systems such as Arrow 3 are designed for this role. If a missile passes through that layer, another set of systems intercepts threats in the upper atmosphere. Systems such as David's Sling and THAAD are designed to destroy medium-range ballistic missiles and some high-altitude threats. The final layer is point defense. It protects specific cities or military installations from short-range rockets, drones, and aircraft during the final moments of flight. Systems such as Iron Dome and Patriot operate at this level. The purpose of this layered system is redundancy. If a missile slips past one layer of defense, another still has a chance to intercept it. The final stage of a ballistic missile's journey is known as the terminal phase. This begins when the warhead re-enters the atmosphere and rapidly descends toward its target. At this point, the warhead may be traveling at speeds exceeding Mach 10, leaving only seconds for defense systems to respond. Once an interceptor reaches its target, it destroys the incoming missile in one of two ways. Some systems use kinetic interception, also known as hit-to-kill. Interceptors such as those used in Arrow 3 or THAAD do not carry explosive warheads. Instead, they collide directly with the incoming missile at extremely high speeds, destroying it through sheer kinetic energy. Other systems use blast fragmentation warheads. Interceptors such as those used in Iron Dome or Patriot explode near the incoming projectile and destroy it using a cloud of high-velocity metal fragments. While ballistic missiles travel high into space, cruise missiles present a different challenge. Cruise missiles fly much lower, often just 30 to 100 meters above the ground, and can maneuver around terrain to avoid radar detection. Because of this, they are intercepted using air defense radars and surface-to-air missile systems, designed to track moving aerial targets. Systems such as Patriot and David's Sling can intercept cruise missiles by launching maneuverable interceptors that chase the target through the atmosphere. Unlike ballistic missiles, cruise missiles fly more like aircraft. They are harder to detect but generally slower, often traveling at subsonic or low supersonic speeds, which makes interception possible once they are tracked. Missile interception remains one of the most complex challenges in modern warfare. Even with the most advanced technology, however, no missile defense system is perfect, which is why layered defense remains the cornerstone of modern air and missile defense strategies.